This video continues the discussion on volume and the word problems that are associated with it. We have a couple of examples from the booklet that we're going to do together. Example 4, carrying on, this is the second video for volume practice, says a spherical air tank is 12 inches in diameter. Find the volume of the tank in liters, around the nearest tenth. So if the desired unit is liters, what comes into my mind, and it should come into your mind, is the conversion factor that says 1,000 cubic centimeters is equal to 1 liter. Are there other conversions you could use to go from cubic inches into liters? Probably. Although you won't have access to that information on a quiz or a test. But you will, because you will have learned this, always be able to use 1,000 cubic centimeters is the equivalent of 1 liter. Therefore, let's start with a picture. Now, it's impossible for me to draw a 3D sphere. So I'm going to draw a circle. Well, that's just pitiful. And try to make it look 3D. It's impossible. But I want you to think about 3D. Picture some kind of a balloon type shape. You would have to have a formula to start. The volume of a sphere needs to be solved using the formula either 4 pi r cubed divided by 3, or in some situations is written as 4 over 3 and then pi r cubed. Same thing, you'll get the same answer whether you do pi times r cubed times 4 then divided by 3, or do it as 4 divided by 3 times pi times r cubed. The deal is, my goal is to get my answer in liters, so I'm going to take my dimensions that I'm given and convert it into centimeters. So 12 inches, the first thing that I would do with that is find the radius, which is 6 inches, and then convert inches into centimeters. So say you went to your famous table and you wrote down the fact that 1 inch is equivalent to 2.54 centimeters. Then you could say, okay, well, 6 inches is going to be equal to how many centimeters? Obviously, the answer has to be the product of 6 times 2.54. So 15.24 centimeters. And that is your radius. To complete the problem, you fill into your formula 4 times the value of pi times the value of r, but you must cube the r first. So 15.24 times 15.24 times 15.24, multiply it by pi, multiply it by 4, and then divide it by 3. And you're going to get an answer of 14,826.66 cubic centimeters. So now that we have our answer in cubic centimeters, we can use the conversion that there's 1,000 cubic centimeters in 1 liter. If you want to set it up proportion, you could do that too, I suppose. 1,000 cubic centimeters is equal to 1 liter. So how many liters would there be? In 14,826.66. Long story short, you're going to divide it by 1,000. And your answer is going to be, to the nearest tenth, 14.8 liters. That's the capacity of the tank in liters. You could have found the capacity of the tank in cubic inches. You could have found the capacity, we obviously did it in cubic centimeters. Probably could have even done it in feet. 12 inches is clearly 1 foot. 1 foot cubed would be 1 times pi times 4 over 3. Much easier number to work with, but not the desired unit. The volume of a sphere is 4 pi r cubed over 3. The last question is a bit different, and it's the only question in the practice that I gave you that requires you to find the surface area. So to start the question, you need to understand what surface area is. Surface area would be if you're going to take an object and cover the entire outer surface with something like paper or shrink wrap or anything at all. This question has a hemisphere, which is a half of a sphere. So it has the rounded shape, half of a sphere, plus it also has the bottom, which is a circle. So picture a circle. On the bottom it has to be wrapped or covered. And then the three-dimensional sides, which are basically like a basketball, half of a basketball, covered in the same type covering. So there's two parts of this question. The area of a circle is, of course, the area of a circle. That'll be no trouble to find that. The area is going to be pi times the radius squared. But the area of a sphere, the surface area of the sphere, you need to know a formula. And I would give this to you, I would never expect you to know it. The surface area of a sphere is found by taking 4 times pi times the radius squared. Now we only happen to have a hemisphere, or a half of a sphere. So we're going to divide it by 2. So of course you're going to really get a new formula. If you wanted to just do 2 pi r squared, that would work. But we'll follow the rules. The radius is 3.6 meters. It doesn't tell you what unit to put your answer in. So let's assume that the answer will be in meters as well. So we start with what we're given. 4 times pi times 3.6, and we'll square that. So 3.6 times 3.6 times pi times 4. That works out to be 162.8601. And that's square meters. And that covers basically the curved edges of your half basketball. And then you have the bottom of your sphere, the flat edge. So pi times the radius of 3.6 squared. So 3.6 times 3.6, close to 4 times 4, 16. Below that, times by 3. So the answer, 40.715, is what I rounded it to. 7150 40, and we're trying to find the total surface area. You have to, of course, add these numbers together. I noticed a mistake that I made. I forgot to divide my surface area by 2 because it's only half of a sphere. It's a hemisphere. So I'm going to go back and edit that, and I'm going to take the 162 and I'm going to divide it by 2. So 81.4300 is pretty accurate. And I'm going to add that number, which is the hemisphere side, the outside of the rounded edge, plus the circle on the bottom. And we're going to add them together, and we will get, let's line them up, old-fashioned math. $122.145, correct rounding, 122.15 balls. That's square meters. And that's your surface area. Although there's no more questions here, I want to remind you of a couple things. You're also responsible to work with cones. So a cone is essentially a cylinder that's not completely, well, a cylinder divided into 3 sections would be a cone. So if you take the circle, pi r squared, multiply it by the height, that gives you a cylinder, but because the shape of a cone meets at a point in the middle, you're going to take that answer and divide it by 3, because a cone is actually 1/3 of a cylinder. That formula you should have in your memory bank. You're going to need to know that. You're going to have to know, of course, your cylinder. But this one, oh, it's a terrible picture, but your cylinder is given to you in the formula sheet. So if you know one, you can find the other. A cone is essentially 1/3 of a cylinder. You have to know a rectangle, rectangular prism. You have to know a sphere. So your sphere is hard to draw 3D. We just did that one. Of course, it's 4 pi r cubed divided by 3. All these units will have 3 dimensions. You have a radius squared times a height. That's 3 different numbers. A radius squared times a height. A radius cubed. That's a 3rd dimension. A rectangular prism is also 3 dimensions. So you have basically a box. So a length times a width times a height. So 3 dimensions. 1 unit cubed. For square surface area though, say you had a box. And this is a box that's rectangular in shape. And then you have to give it walls to make it 3D. One thing I want you to think about, and this will be a classic test question, is to find the surface area of a box. So it's going to be your job to be able to visualize the shapes. You're going to have a side view, so this one, and that's going to be, say we have dimensions. This is your length, this is your width, and this is your height. This is your length, and this is your width. So you're going to have a length times a height. That's like the sides. You're going to have the ends, which is, I can only show you one end in the 3D picture, but that end would be the width times the height, and there's 2 of those, and there's 2 of these, and the 3rd dimension, so to speak, the 3rd size, shape, would be the top and the bottom of the box. And the top and the bottom would be, if you think about wrapping something, the length times the width. And there's 2 of those sides. So whenever you're asked to the surface area, and you will be, of a box, there's going to be 6 sides. You can do 3 sides and then double the whole thing. That'll give you the total surface area. So please remember, always read the question first. Look for the unit that you're desired to give it in. So if it says cubic inches, make sure all your dimensions are in inches. If it asks for centimeters, give them all in centimeters. If it asks for meters, change all the meters first. Once you get that done, the question should be fairly easy. Good luck.